Hello, welcome friends. Me Anila. The topic of my discussion is toughest numericals of stoichiometry. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you how to solve toughest numericals of stoichiometry. Example number 1. How much amount of aluminum sulfate is required to react completely with 40 gram sodium hydroxide in the following reaction? So in example 1, we have to find the amount of aluminum sulfate that is required to react completely with mass of sodium hydroxide is given 40 grams. Reaction is aluminum sulfate plus 6 sodium hydroxide gives us 2 aluminum hydroxide plus 3 sodium sulfate. So we have to find aluminum sulfate and sodium hydroxide is given. Solution. First of all, molecular weight of sodium hydroxide we will calculate. 1 is the number of sodium atom into 23 is the atomic weight of sodium plus 1 is the number of oxygen atom into 16 is the atomic weight of oxygen plus 1 is the number of hydrogen atom plus into 1 is the atomic weight of hydrogen. After solving, molecular weight of NaOH is calculated to be 40 gram per mole. Calculate moles of NaOH. Amount divided by molecular weight. 40 gram is given already. Divided by 40 gram per mole. Answer is 1 mole. So we have calculated moles of sodium hydroxide. Now, as I have discussed earlier, 6 mole sodium hydroxide reacts with 1 mole aluminum sulfate. So, the 1 mole sodium hydroxide reacts with, we will multiply 1 mole with 1 mole and divide by 6. The answer is 0.166 moles aluminum sulfate. Now we have calculated moles of aluminum sulfate. Now we have to find amount of aluminum sulfate, but before this I will tell you how to calculate molecular weight of aluminum sulfate. 2 is the number of aluminum atom into 27 is the atomic weight of aluminum plus 3 is the number of sulfur atom into 32 is the atomic weight of sulfur plus 12 is the number of oxygen atom 3 4 the 12. So 12 is the number of oxygen atom into 16 is the atomic weight of oxygen. After solving, the molecular weight of aluminum sulfate is calculated to be 342 gram per mole. Now we have calculated moles of aluminum sulfate, molecular weight of aluminum sulfate. Now we will calculate amount of aluminum sulfate is equal to, we will multiply moles with molecular weight. 0.166 moles into 342 gram per mole. The answer is calculated to be 56.772 gram aluminum sulfate. So this is the right answer. Example number 2. 15 gram of calcium carbonate reacts with 100 ml of 1 molar HCl. Find the limiting reagent and the mass of carbon dioxide produced in the following reaction. So the reaction is calcium carbonate reacts with 2 moles of HCl to form calcium chloride, carbon dioxide and water. In this reaction, mass of calcium carbonate is given 15 gram. HCl is 100 ml of 1 molar. We have to find the limiting reagent and we have to find the mass of carbon dioxide produced. Limiting reagent is the reagent that is producing less moles of product. Now, solution. First, we will find the limiting reagent. Molecular weight of calcium carbonate we will calculate. 1 is the number of calcium atom into 40 is the atomic weight of calcium plus 1 is the number of carbon atom, 12 is the atomic weight of carbon, 3 plus 3 is the number of oxygen atom into 16 is the atomic weight of oxygen. Molecular weight of calcium carbonate is calculated to be 100 gram per mole. Now we will calculate moles of calcium carbonate. Amount of calcium carbonate is already given, 15 gram divided by molecular weight is calculated 100 gram per mole. Answer is 0.15 moles. Now moles of calcium carbonate we have calculated. Now we have to calculate moles of HCl. We know that HCl is equal to 100 ml into 1 molar. We will multiply 100 ml with 1 molar because 1 molar means moles per liter. So liter is cancelled and answer is 100 millimoles. And milli means exponent minus 3. When we will multiply 100 with exponent minus 3, answer appear zero point 0.1 moles. So moles of calcium carbonate is calculated 0.15 moles. Moles of HCl is calculated 0.1 moles. Now we have to find which of them is a limiting reagent. If calcium carbonate is limiting reagent, so in the equation 1 mole calcium carbonate produces 1 mole carbon dioxide. So 0.15 moles calcium carbonate produces 0.15 moles carbon dioxide. So calcium carbonate is producing 0.15 moles carbon dioxide. If HCl is limiting reagent, 2 moles HCl produces 1 mole carbon dioxide in the equation. So 0.1 moles HCl produces, we will divide 0.1 mole by 2, answer come 0.05 moles carbon dioxide. So calcium carbonate is producing large amount of carbon dioxide while HCl is producing less moles of carbon dioxide. So because HCl is producing less moles of carbon dioxide, so HCl is a limiting reagent. Now we will calculate the amount of carbon dioxide. First we will calculate molecular weight of carbon dioxide. 1 is the number of carbon atom into 12 is the atomic weight of carbon plus 2 is the number of oxygen atom into 16 is the atomic weight of oxygen. Molecular weight of carbon dioxide is calculated to be 44 gram per mole. Now, amount of carbon dioxide, we will place that amount which is less, that is 0.05 moles multiplied by 44 gram per mole, the molecular weight of carbon dioxide. Amount of carbon dioxide is calculated to be 2.2 grams. So we have find the limiting reagent and amount of carbon dioxide produced. Example number 3. How much iron can be obtained from 32 gram oxygen through these reactions? So we have to find iron that is obtained from 32 gram oxygen. Mass of oxygen is given and the two reactions are given. 4 iron plus 3 oxygen gives us 2 Fe2O3. Fe2O3 plus 3 carbon monoxide gives us 2 Fe plus 3 carbon dioxide. So these are two reactions. The question is very tough, but the answer is very clear. 32 grams of oxygen is given and we have to find the iron obtained, that is the product in the second reaction, iron in metallic form. Solution. First we will calculate molecular weight of oxygen is equal to 2 is the number of oxygen atom into 16 is the atomic weight of oxygen. Molecular weight of oxygen is 32 gram per mole. Moles of oxygen is equal to, we will place amount 32 gram divided by Molecular weight of oxygen 32 gram per mole. Answer comes moles of oxygen is equal to 1 mole. In the reaction 1, 3 moles oxygen produces 2 moles iron oxide. So 1 mole oxygen produces, we will multiply 1 with 2 and divide by 3. Answer appears 0.666 moles Fe2O3. In the second reaction, 1 mole Fe2O3 produces 2 moles iron. So 0.666 moles Fe2O3 produces. We will multiply 0.666 with 2 and divide by 1. Answer appears 1.333 moles iron. Now the moles of iron are calculated. Now amount of iron is equal to, we will place moles 1.333 moles into atomic weight of iron 55.85 gram per mole. After multiplying, amount of iron appears 74.448 grams. So the amount of iron is calculated to be 74.448 gram. In this way, we can perform stoichiometric calculations. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.